Okay, moving on to 2A, circuit analysis. This section, the way I look at this section is really, the transition into the analytics, the transition into the more advanced, sophisticated calculation. And it starts out pretty nicely because three-phase systems, we've dealt with them in FE, single-phase circuits, DC circuits, we've dealt with them, and along with phasor diagrams, we've dealt with them in FE. Symmetrical components and per unit were the only two advanced topics over here that will, again, as you guys know, in fault analysis, especially make a comeback in transmission lines, make a comeback to an extent in power flow as well as power system stability. And those of you who work in the industry, single line diagrams, you look at them day and night, right? So this is sort of just a fairly simple, straightforward topic. So how are we going to rate three-phase systems? Again, in the context of PE power, we went through it in a lot of detail. We paid a lot of attention to, the small letters are used for this and the big letters are used for that. And we did we made sure that we got a good handle on square root 3 and 30 degrees. Did multiple derivations and so on. So let's call it medium. Symmetrical components and per unit. So symmetrical components, we looked at what is really the application, what they help us with. And I told you at least when we're going through circuit analysis, that right now we'll just focus on the math portion of it. And when we come to fault analysis, we're going to look at its application, right? So symmetrical components, guys, how do you guys rate it? Medium to hard? Medium? Okay, let's call it medium. Okay. And per unit systems, guys, how are we going to rate per unit systems? Easy to medium, medium, medium. So let's call it medium. Okay. Now, phasor diagram, circuit analysis, DC circuits. This is essentially a repetition of FE electrical, right? We did go through RCRL in a little bit more detail. We did look at the single phase circuit variations. Remember the 3-4 different types of single phase circuits, the center tap circuit, the 208 three-phase circuit, right? And so on. So yeah, so how are we rating it? Easy to medium? So okay, let's call it easy to medium. All right, and the SLDs are easy, right? As far as SLDs are concerned, under the title of single line diagrams, I think they have ANSI symbols. So please make sure you understand the ANSI symbols. If a single line diagram is shown at you, and we did review, even in production, a couple of single line diagrams when you're going through SLDs, we looked at them through schematics as well. So we have interjected single line diagrams and 3-line diagrams and schematics all along. Okay, so this small section, subsection, is super important because of these two guys here. 3, I would say. These 3. From this point onwards, you cannot ignore them because they're going to keep on making comebacks after comebacks and comebacks, right? So if somebody was complacent in these sections, and I think I made a point when we were going through them that, listen, guys, we need to really know them inside out. And I'm not saying that it's by spending extra hours that you're never going to feel uncomfortable dealing with per unit system or symmetrical components or three-phase systems, right? There are always curveballs that can be thrown and tangents that can be taken, but it is a worthwhile investment of your time, not only in the context of this particular subsection, but how it really impacts the rest of our P power exam prep. Okay. Devices and power electronics. So back when the exam used to be open book, okay, battery characteristics and ratings, that's before December 1st, 2020, used to be a very vague topic because either you go super deep in battery, and battery design, you guys know, is an evolving field, right, of energy storage. And all the big name companies, the Fords, the German companies, and Teslas, in addition to automation, not automation, but autonomous vehicles, design, the race is really in increasing the battery longevity overall throughout the lifetime, and also charging them faster, holding the charge, reliability, and everything. So this is, as far as EVs are concerned, this is at least one of the top 3 areas of research. So it's an active area of research, right? Now, when you talk about battery characteristics and ratings, when it was open book, it was like, how do you study for it? But thankfully, with the reference handbook, they have at least narrowed it down with the help of some good quality references. And we went through, the multiple equations, the terminology, and the tables, and some of the even calculations, right? So how are you guys gonna rate battery characteristics and ratings? Medium, easy to medium, hard? Okay, let's just call it medium then. All right. And power supplies. So power supplies, see, it seems such a benign topic over here, but we know what is hidden in there, right? Arguably one of the most difficult topic, okay, in an absolute sense, right? Seems so cute, so innocent. Power supplies, okay, just a voltage source and a current source, right? Now, the way we sort of put everything in context was that this is one of the lightest subsections of the entire exam. 7 questions in total. So even if I was to divvy up all of these questions, right? Let's say they were 8 instead of 7, just to keep things simple. And they're 4 topics. And if I was being, just equally dividing all of them. So at best, power supplies should get how many questions? 2 questions, right? Right. Now you got to ask that for 2 questions, is it worth, deep diving into inverters, deep diving into different configurations, the circuits, the graphs, the equations, the variations, right? And throw in the capacitors, the waveform tracing, right? Now, I have never ever recommended you guys to skip anything, okay? And those of you coming from FE Electrical, I tell my students, this is this type of discussion that comes up in computer networks. Why? Because computer networks, those of you who have taken computer networks without any background in computer networks, know that the effort to reward ratio is completely skewed, right? They have about 18 pages of reference material for 4 to 5 questions. One of the least weighted topics, in fact, the least weighted topic on the exam has been assigned one of the most, in fact, I think the most amount of content, right? Ranging from protocols to, network models, and then algorithm security. So much stuff for 4 questions. Okay, 4 to 5 questions. Same thing over here. If you look at it, if I equally divide, and again, there's nothing forcing them, or they have a range now that they can ask. They don't tell you individual basis how many questions, right? So effort to reward ratio is missing. Having said that, what complicates this further, right? This is like a Christopher Nolan movie, right? Has anyone seen Oppenheimer? I saw Oppenheimer last weekend. No, actually, it was this week. It was actually this week. Could never take a break. 3-hour long movie. So stressful. So stressful. Like all of his movies, right? I would recommend it if you are, well, if you're a fan of Christopher Nolan movies, you're going to love it, right? So he has a different type of take, right? Right? So Dark Knight, Inception, Interstellar, Shutter Island, and now this. And I think I'm missing probably one or two other big ones. But yeah, so it depends. It is an acquired taste. So my wife did not accompany me, right? I watched it with my friends. So it's not for everyone. She was more interested in watching Barbie. Yes, she actually went to Barbie, and I didn't watch Barbie. But yeah. So anyways, coming back to this, in terms of, the last thing I was going to say was that, when you look at the NC sample exam now, right? If you look at NC sample exam, how many questions did they have from power supplies or power electronics? They had 6 questions, 6 or 7 questions. So but I keep on reminding you guys, the NC sample exam is actually a little bit outdated, because a bunch of those problems are the same problems that when I was preparing for my P-Power exam. Okay. So when you look at it, they essentially took all 7 questions and stuffed them with power supplies. So if that is the case, then you are missing out on potentially 9 to 10% of the entire exam. And that would be a fatal blow. I don't think most of the candidates would be able to recover from that if 10% is taken away from them on the exam. So we got to be careful. So what was our approach? Did we take a shortcut? Do we ever take shortcuts? No, right? I tortured you guys with a lot of content, right? Unintentional torture. Right. And the reason for that was, okay, if we don't know how to do waveform tracing, we're going to learn how to do waveform tracing, right? We're going to go from easy to medium to difficult, right? And we looked at if the specification has these many circuits, we're going to look at variations of those circuits, right? So I think you guys are over prepared if you went through the live training and on demand. And but I recognize that the effort to reward ratio is this. So let's just call it hard, right? Some of you guys were using H++, so might as well throw H++, okay? It's a difficult topic. Relays, switches, ladder logic, and again, This is one of those areas which very simple concept, right? But again, what's the issue here? Handbook does not contain any detail, right? The handbook does not contain any detail, right? So what we had to do was we had to improvise. We had to know the basics of relays. The relay discussion came up again in section number 4. And I was like, guys, we're going to revisit it, right? So we were sort of cruising at a high level with relays, with switches, different terminology, different types, with ladder logic. We looked at schematics and whatnot. How would you guys rate this? Easy? Okay, let's call it easy. VFDs. How much content do we have in the reference handbook on VFDs? Tons of content, right? There's only one paragraph, a total of 6 lines, I believe, right? But in those 6 lines, they actually say scalar and vector control, okay? Now, you can either just know that V by F has to be maintained for scalar, and for vector control, we essentially use the DC drive principles of DQ currents, and that gives us greater control or decoupled control over torque and speed. Well, if I tell you this, it's just that you're taking my word for it without really knowing the mechanic, right? So in the VFD section, what we did was we basically took a deep dive into scalar, right? Went through the math, went through different variations as to keeping the torque constant, keeping the power constant, and this and that. So that was our V by F control. And then in vector control, I introduced the mathematical concepts of the Clark transform and the Park transform, this and that, and help you guys explain that when you have the DQ currents, how can you decouple the torque and speed. So it was pretty advanced, right? But worth it, right? Because we've seen these V by F type of questions pop up in the NC sample exam a couple of times, right? And that paragraph, I don't think that, if I was to just test you a little bit deeper, that paragraph is gonna not help you, right? So, and then supplementary content on different types of variable speed drives. At this stage, you guys can completely skip that. Lots of details on AC drives and the cons, different types of inverters that are used, and so on and so forth. So how are we going to rate VFDs, guys? Medium due to lack of information. Okay, I agree. All right. So that buttons up. So this basically wraps up our section number 2. Interesting section. Serves as a launching pad for discussion that we have in sections 3 and section 4.